The graph of fx is shown below. Man, they should be more specific. It's the blue graph, right? So we need to use the tools to graph the line tangent to f of x at x equals -1. So here is x equals -1, and here's the dot on the graph, right? Now that's definitely not the tangent line. That might be the tangent line. That's a little bit closer, right? It's supposed to touch at just one spot. Well, they give us 2 points. I'm trying to think of the easiest way to do this. I think I got to bring it to a whiteboard. Because we can find out what that slope is. Instead of just like trying to eyeball it on the graph, we can find out exactly what the slope is supposed to be by finding the derivative. So in a different video, if you haven't seen this power rule yet before, you definitely want to check that out, because to find the derivative, you don't need the limit definition of a derivative anymore. You can just use the power rule. That 3 multiplies to the -2, and then it gets reduced by 1. And then that 1 comes down and multiplies out front, and then the power gets reduced by 1. So it's x to the 0, or just nothing. They want the tangent line of f of x at x equals -1. In other words, they want to know this. What's the slope? Remember, this is notation for derivatives, so notation for slopes. What's the slope at x equals -1? So if you plug that in here, if you plug -1 in for x, it gets squared, but then it gets multiplied by -6. So that's -5. The slope is -5. So this is definitely the dot when x is -1. This is on the line, on the blue line. If the slope is -5, that means we need to fall 5. So -3.5, -4. That's down 2, down 3, down 4, down 5, and run to the right 1. Or you can think about it in reverse. You go up 5, so we start on -2.5 on the y-axis. So there's up 1, up 2, up 3, up 4, up 5, and run to the left 1. Oh, that last one I didn't run fully to the left because it's going by 0.5s. There's up 1, up 5 to the left 1. Or you could, like we said, you could go down 5, 3, 4, 5, and to the right 1. Whoop. No way. -6, let me see if I get the derivative. -6x to the second plus 1. So I plug in -1. -6. Huh. What did I do wrong? I went down 5 to the right 1. That's definitely the slope. We got the right slope, right? Plug in -1 squared, it's 1. -6 times 1 is -6. -6 plus 1 is definitely -5. So go down 5. So I start -2.5, so we go down 5, you're down at -7.5, and to the right 1. Well, the slope is -5. To find the y, oh, maybe that's what they need is the y-intercept. They shouldn't, though, unless they say to graph by using the y-intercept. So what I'm doing is I'm constructing the full equation for the line instead of just using the idea of slope. We need a point that's going to be the point of the tangent. So it's at -1, -2.5 for that slope. So if I plug these in, so if I plug in -2.5 in for y and -1 in for x, that's 5. Subtract, no, we get the same thing. I must have done something wrong. I mean, you could go up 5, so 1, 2, 3, 4, 5, and to the left 1. Oh my gosh, it's because my original dot wasn't on there. Okay, so that's a good lesson, I guess. I thought I dragged this dot onto the blue line, but if you look at it carefully, it's not exactly on the blue line. And I should have verified that, because you could just plug in -1 into this function and see if it spits out -2.5, and it wouldn't. So it's just because that original blue dot wasn't there. So if you get one wrong and you don't understand why, just check to see if you've got that starting dot in the right spot. I did not for mine. Find the equation line. Okay, so let me pull this up. on the whiteboard. This is what we just did, just with a bit more of a complicated function. So the equation of the tangent line at x equals -1. That's y equals mx plus b, because the tangent line is perfectly straight. We can get the slope real quick by first finding the derivative. So that 3 comes down, and then the power gets reduced by 1. The 2 comes down and multiplies, and the power gets reduced by 1. And the derivative of a constant is just 0, so that's gone. So this is a machine that will spit out slopes for you. We wanted the tangent line, so we want to plug in -1 into the derivative. So that's -3 plus 10, so that's 7. So the slope of the tangent line is 7. Now to find the y-intercept, we got to have a point from the function. So let's just plug in 0. You can plug in any point you want. Wait, no, because it's the equation of the tangent line. You have to plug in -1. Ooh, almost made another mistake. So if you plug in -1 into this function, -1 to the third is -1. Applying a negative sign, that makes +1. So +1 minus 5. This is going to be a +1 when you plug in -1 in there. So +1 minus 5 plus 2, 4. So that gives us -2. So we can plug in -2 for y and -1 for x, and then solve for b. Add 7 to both sides, so we get a y-intercept of 5. So this here is 5. So we get y equals, our slope is 7x, and our y-intercept is 5. Okay, let's see if we can get another graphing problem. So this problem asks us to find the equation of the normal line. A normal line is perpendicular to the tangent line. So let's say this is your original function. You got this, one different color. You got this for a tangent line. The normal line would just be perpendicular at that point of tangency. So it's just going in the opposite direction. So just need to flip and change the sign of the slope. Okay, so if we need a normal, then we need a slope, and that can be gotten from the derivative. Oops. So when we evaluate this derivative using the power rule, the 3 comes down, the power gets reduced by 1. The 1 comes down, multiplies, the power gets reduced by 1. And the derivative of a constant is 0. So we need to plug in -1. So that's -3 minus 4. So it makes -7. I think that's it. That's the slope. But we wanted the normal line. So we want a perpendicular slope. So if you remember from algebra, that's 1/7. Change the sign and flip it. So to make the equation of the normal line, it's 1/7 x plus some y-intercept. Now normally this is where we plug in a point. We need to figure out what that y-coordinate is that corresponds with that point of tangency at x equals -1. So if you plug -1 in here into the original function to get your y-coordinate, -1 makes a +1. And then -1 times -4 makes a +4. So 1 plus 4 is 5. 5 minus 2 makes 3. So we can plug in 3 for y, -1 for x. So this is -1/7. You want to add 1/7 to both sides. So that's 3 1/7 for the y-intercept. Or in just improper fraction forms, it's 22/7 for b. So we have the equation of the normal. It's 1/7 x plus 22/7 for y. Okay, it's comeback time. So we're supposed to graph the tangent line at x equals 1. Let me get this point right to start off. There's x equals 1. If you plug in 1 in there, that makes 6. Okay, so that is definitely on the right spot this time. So we want to know what the slope is. So we can take this and evaluate the slope. We'll find the derivative, and then we can plug in 1 to find out the slope at x equals 1. And want the slope at x equals 1. So let's do the derivative using the power rule. That 2 comes down and multiplies out front. And then the power gets reduced by 1. The 1 comes down and multiplies, and the power gets reduced by 1. So this is the derivative. And we need the derivative at x equals 1 to find out what the slope is. It's a negative 2 plus 3 makes 1. So our slope is 1. At this point, the tangent line has a slope of 1, so it means it should go up 1 to the right 1. So if we start at 1, 6, we go up 1 on the y-axis to 7, to the right 1 to 2 on the x-axis. Okay, so yeah, that first one just messed up with the starting dot. Oh, same thing here. The derivative of this function is going to be negative 6x squared plus 2. So if you plug in negative 1 in there, that's negative 6 times 1 makes negative 6, plus 2 makes negative 4. So we got a slope of negative 4 at x equals negative 1. A slope of negative 4, so that means go down 1, 2, 3, 4, and to the right 1. This is the dot that's on the graph, on the blue graph, at x equals negative 1. And then I'm supposed to find the tangent line. I'm supposed to graph the tangent line. So I quickly found out the slope in my head using the derivative. That's something you'll definitely want to do on paper, like I've been doing with these past few problems. But the slope, the derivative function should be negative 6x squared plus 2. And if you plug negative 1 in there, you get a slope of negative 4, which means you go down 4 to the right 1.